Hey guys, so today we're going to do a stack problem, and we're going to make it a little bit more interesting than a typical stack problem because we're going to say that we're using an array to store all the data for our stack, and we can have as many stacks as we want that are all going to have to be stored in this one array. So it's going to make things a little bit trickier and a little bit more fun, so let's go ahead and get started. And first of all, I have a couple questions. The main question I have is, what are the elements of this stack actually going to be? And it doesn't really matter in this case. The one constraint is going to be that I'm going to say that all of the different stacks within our stacks object are going to have to be of the same type. So I can have 5 stacks of integers, for example, or 5 stacks of strings. But in this case, I'm just going to say integers, so we'll have n stacks of integers. And the other thing I want to be sure that I think about, although we're not going to deal with this directly right now, is how am I going to deal with the case when my array is full or my array is empty? So if it's full and I try and push something and there's no room to push anything and we've reached the maximum capacity of our stack, then what am I going to do? And if it's empty and I try and pop, what is the appropriate response for that from our object that we're creating? So it's something to think about, although not super critical right now. So I'm going to start thinking about this. We could, in theory, have only one stack or 2 or more than 2. And these are all going to be sort of different cases. But I'm just going to start with the simple case first. And you can do this in your interview. Just think about, what are the special cases, and then how are we going to generalize to any case. So let's start with n equals 1. So I'm creating just a single stack. And I can do that pretty simply because I'm going to initialize my array. And so when I initialize it, all the values are going to be 0. And then I'm just going to keep a pointer to the next available element in the array. And so I'm going to say when I add an item to the stack, I'm just going to put the item there, and then I'm going to increment this pointer, and I'm going to add another item and increment the pointer, and so on and so forth. And then when I pop an element, I'm going to check if this is 0, and if it's 0, then I know that nothing's been added to the array, so I'll throw an error, or added to the stack, so I'll throw an error. Otherwise, I'm going to decrement this by 1 and then return the value, and I don't actually have to remove it from the array because it's going to just get overwritten, but I'm just going to return this value, and then the next time I push a value like 3, it's just going to replace the value that was currently there. So that's pretty straightforward. Our capacity is always going to be the size of the array no matter how much we push and pop, because our next available is always going to point to the top of our stack, right? So we're always going to move it back and forth, and we're never going to end up with any issue where there are cells in the array that are not being used that can't be used in our context. So that's good. And now if n equals 2, we could do this one of 2 ways. We could say so we're going to have our array, and it's going to be the same thing, although I'll add one more. And so we could do 2 things. We're going to need 2 pointers. So the naive way to do it would be to just split this right down the middle. And we're going to put a pointer in each of these places, and that's going to be the top of the first stack and the top of the second stack. And then when we add to stack 1, we're going to add 1. And then when we add we're going to put it there, and we're going to increment this pointer. Oops. We're going to increment this pointer. And then when we add to this stack, we're going to add, 1 and increment the pointer, 2 and increment the pointer, and 3 and increment the pointer. And now in this case, we're going to, when we try and add another thing, we're going to see that this pointer is out of the range of the array. So we're going to say that stack 2 is full. But we still have empty space in our array, right, that we're not using. And we don't want all of the stacks to be fixed sizes. We want to use the total capacity for whatever stack fills up first. And so what we can do, which is tricky a little bit, although you'll probably have seen this before, is we can start our pointers from opposite ends. And so we're going to, when we add to this array, we actually decrement the pointer, and we add 2, and we decrement again, and these just go in opposite directions, and they move towards each other, and they meet in the middle. And that way, we're always going to use up all of these cells in the array, even if one of the stacks is much bigger than the other. So that's good a good way that we can make sure that we're using all of our data. But now we have to think about the case of n equals 3 or more. And this is going to be the general case, and this will work for any number. We're going to make something that'll work for any number of stacks, including our simpler n equals 1 and n equals 2 cases. So when we do this, we could do what we were talking about for the naive solution for the n equals 2 array, right? We could put a pointer here, we could put a pointer here, and we could put a pointer here, and we could all move them all forwards. And that obviously runs into the same problem we were running into the first time. We could do maybe slightly better, depending on the implementation, by dividing it like this, and we'd basically have the third stack go backwards, the first stack go forwards, and some stack in the middle somewhere that we're gonna, try and align it, but we're still potentially gonna end up with empty space. So this solution is not gonna work. So what we need to do is sort of rethink our approach here. And so what I'm gonna do is I'm going to have to allocate multiple arrays, and I'm going to use these arrays to track different information. So I'm going to go ahead and show you what this is going to look like. So we're going to have 3 arrays, and the first is going to be the top of stack array. And this array is going to point to, when we have n stacks, we're just going to index the stacks 0 through n minus 1. And that's how we're going to reference them. And top of stack is going to be an array that maps the stack number to the position in our array that represents the top of that particular stack. So top of stack is going to be, let's say that in this case, we're going to stick with n equals 3. So we're going to have 3 stacks. So and we're going to initialize these to -1. So we'll go into a little more detail on this in a second, but we're going to have the top of the stack, and then we're going to have our data array, which we had before. And that's this array here that stores the actual values in our stack. So let's call that stack data. And that is going to be of length, size of array, whatever, size of stack, whatever that is. So in this case, we're using 6. So like that, and then finally, we're going to have an index array, or a next index array, which is what I'm going to call it. And this array is actually going to serve 2 purposes. So we can go ahead and also initialize these to 0. Well, actually, let me talk about how we're going to initialize this in a moment, but we're going to have 6 elements in this array. So let's just line these up so that they're a little bit easier to see. And now, here's what's going to happen. So when we add an element, so we're going to have this next index array, and the next index array is going to serve 2 purposes. The first purpose it's going to serve is it's going to tell us if we're at a given node, what the next available node is. So what the next available index is that has not been set and is not being used in one of the stacks. So that's how we're going to initialize it, because initially we're not using any items in the stack. So we're going to initialize this to 1, 2, 3, 4, 5, and -1. So what this means is if we get item 0, and then we need one more value, which is going to be called next available. And that's just going to be a single integer, and that's going to start as 0. So let me just align these again. So next available, when we want to add an item to our stack, we're going to get next available, and next available is going to tell us which index in the data array to put the data at. So in this case, next available is 0. So let's say we want to add 1 to this. We want to add 1 to stack number 0. So that's going to basically look like so we say stacks.push, and then we're going to have the stack index, and we're going to have the value that we're pushing. So the stack index is 0, and the value, let's say we want to push 5. So we're going to come in here and we're going to get the 0th stack, and we're initializing these all to -1 because -1 is going to say that there is no value in that stack yet. So if the top of the stack is a 0 or 1 or greater, that means that there is at least one value in that stack, and that top value of that stack is at the index represented in top of stack. So to add it, we're going to go and we're going to get next available, which is going to be our first element in the set of empty cells in our data array. And so that's going to be 0. So we're going to come here and we're going to set this to be equal to 5. And then we also need to get what the next available is now. And so that's why we have this next index array. So we're going to set that to be equal to 1, which means that we're going to add the next one here. And then we're going to set top of stack to be equal to 0. And then here's the tricky part, the slightly tricky part. We also, when we have a element, we need to be able to get when we pop an element off the stack, we need to get the previous element in that stack and set the top of stack value to be that previous element. So what we're going to do is we're going to actually use this next index for two purposes. It's going to have the purpose of when the element is set, it's going to point to the previous the index of the previous item in the stack. And when it's not set, it's going to point to the next available item. So it's a little bit conceptually tricky because we're going to be doing this array is going to be representing potentially two different things. And if you want to, you could represent the next available as its own array, and then you could represent the previous stack indexes as a separate array, and you would just only be using part of those arrays at any given time, because when all of them are available, then the array for the next stack index is going to be empty because there's nothing in any of the stacks. So you're basically, it works in this case to only use one array, and I'm using it because it's slightly more efficient, but you're using it for two different purposes. So it's a little bit tricky to keep track of, but hopefully this is going to make sense how we're doing it. So when we set this, we're going to set next available to be the previous top of stack. So we're going to set that to be equal to -1, like this, because top of stack was -1 here, and now it's 0. So now let's say we want to add another element to our stack. We're going to, let's say we add 1 and 6, like this. Or let's say that we add 0 and 6. So we're going to add 6 to the 0 index stack. So we're going to come here, we're going to get next available, and we're going to set next available is 1 here, and that's going to be equal to 6. And we're going to save off what the top of stack was, and reset top of stack now is going to be this next available. And then we're going to set this to what the next index is now going to be what the previous top of stack was, which was 0, sorry. Because now that it's set, we have to use it to link back to the previous elements in the array. And finally, we're going to update next available to what next index was before, which was 2. And so now, hopefully, you're starting to see how this is going to work. And then that's all we need to do for this. And then finally, if we wanted to pop off, well, let's actually, because it gets the reason why we have to do all this weird linking is because let's say I push 2 items to stack 0, and then I push an item to stack 1, and then I remove an item from stack 0. Now all of a sudden, I'm not just growing this array forwards, I now have an empty spot somewhere in the middle of the array, and I have to be able to add that back to my available cells list. So we're going to go, let's add 7 to stack number 1. So we come in here, we get 2, which is here. We set the previous is going to be equal to, or the top of the stack is now equal to 2. The previous is equal to the next index, which is now the previous item in that stack, is equal to -1. And next available is equal to 3 because it's pointing to this. And so now we're going to have to make sure that we're doing this all in the right order, right? Because we're reassigning a lot of values. So we're going to have to cache off a couple values so that we can do all this reassignment in each turn. But we'll get to that when we get there. And now let's say I want to pop an element. So I'm going to pop, and we just give the array, the stack number in this case, so pop 0. Now I'm going to come in here and I'm going to say top of stack for 0 is 1. So that is going to be this item here. So I'm going to return this item, and then top of stack, and we don't have to, we're going to add this to the available list. So if you remember way back here with n equals 1, you don't actually have to reset the items in stack data to 0, because you're not actually checking that what the value is before you set it or get it. You're relying on the indices of which items are available. So it's just going to get overwritten when we add a new value. So we don't have to worry about that. So we're going to come here, we're going to get this, we're going to return this, then we're going to set next index is now equal to the current next available, right? Because this one's available now. So we're going to set next available is going to be equal to this index, which is 1, and we are going to set top of stack to be the previous value here, the next index value before we changed it, which was 0. So top of stack is going to be 0. And now what you can see, so now when we add another item, we're going to come in here and we're going to push whatever, and I'm not going to go through the whole thing, but let's say we push 2 and 8, for example. You're going to come in here, you're going to get next available, which is 1. So you're going to push this, and then next available is going to become 3. So the next value is going to get pushed to the third element in the stack. So hopefully that makes sense. It's a little tricky, so make sure you go through the logic and it makes sense to you. And if not, feel free to leave a comment and ask questions, and I'm happy to go into a bit more detail. But let's go ahead and we're going to actually implement this. So I'm going to call this public class stacks, and we're going to have 3 arrays, right? We have to have int top of stack. We're going to have int stack data, and we're going to have int next index. And then we're also going to have int next available. And we know that this is always going to be initialized to 0, right? Because the first available one is always going to be the first element in the data array when we first initialize our stacks. Then public, we're going to initialize this, and we're going to create all the arrays. So stacks, it's going to take in the number of stacks, and it's going to take in the capacity of all, like the size of the data array, right? So we're going to say int num stacks and int capacity. Now we need to initialize our arrays. So the first one we're going to do is top of stack equals new int, and the top of stack is, there's one element for each stack, right? So that's going to be, the size of that is going to be the number of stacks. And that's basically how we keep track of how many stacks we actually have. And then that we need to initialize all the values to -1, because we're going to assume if the value is 0 or greater, then that is an index to the top of that stack. And if it's -1, then we're going to assume that the stack, there are no values in the stack. So we're going to go ahead and initialize this to -1. So for int I equals 0, I is less than top of stack dot length I plus plus, and we're just going to say that top of stack I equals -1. So that's fine, and then we're going to initialize our other 2 arrays. So we're going to say that stack data is now equals new int, and this is going to be the capacity size, right? So capacity, And remember that we are not using this data in this array for anything unless the cell is already set. So we don't have to initialize them to anything. The zeros that they get initialized to are just fine. And finally, we need to set next index, and that's also going to be the capacity size because there's one for each element in the array. So new int in the data array. So finally, we need to initialize it. Remember that in the beginning, it's going to point to each element is going to point to the next element in the array. So it's going to go 1, 2, 3, 4, 5, 6, -1. And the -1 is going to mean that in this case that there is no next available. So if we're referencing one that's -1, that means that the array is completely, or that there are no more available slots. Or if we're popping elements off, it means that we've reached the bottom of that stack. So there are no more elements in that particular stack. So we're going to say for int I equals 0, I is less than next index dot length I plus plus. And then we're going to say that, and actually we don't want to go to the end, right? Because the last value has to be -1. So we're going to set that separately. So we're going to say next index I equals I plus 1. And then finally, we're going to say that next index dot length -1, so this is the last element in the array, is going to be equal to -1. And that's our constructor. So we set up our arrays. And let me also, I'm just going to interject really quickly. So there is another way that you could implement this that's the same concept, but using one fewer arrays. So you could create an object, for example, public, it would be like private class item. And you could include a int value and an int next index. And what you do by doing this is you basically combine the stack data and the next index into one. So rather than having two separate arrays that sort of you're using in parallel, you have both of the data points. So for example, one of the items would have the value would be 5 and the index would be -1 in this case. And you could do it that way, and that's an equally valid. And then instead of these two arrays, you would have one array of items. And it would be exactly the same. And I decided not to do this because there's, especially when it gets big, there's a little bit of overhead for the objects that you're constructing, but you can certainly do that. I think that's a good way to do it as well, and it might make a little more sense or be a little less confusing if you decide you do want to do it that way. But regardless, if you choose to do it that way or this way, the logic is the same. So we're going to come down here, and now we're going to implement push. Well, actually, for starters, why don't I'm going to go ahead and implement I'm going to check if it's full or empty manually, so we're not going to worry about that. Because you might want to check with your interviewer if you should implement is full or is empty for the stack, because those might be very helpful methods for you to have. But I'm just going to focus on push and pop, and I'm going to check those things manually within the methods. So I'm going to say public void push, and that's going to take an int stack and an int value, right? So we're taking the index of the stack, and we're taking the value to push to that stack. So the first thing that we need to do is we need to actually check whether our stack number is valid. So, and this is when we want to check with our interviewer how they want us to handle the errors. So we may, for example, what I'm going to do in this case is I'm going to throw an out of bounds exception if the stack index is not valid. And you can do whatever you want for this. That's just, I think, the simplest solution, but there's certainly multiple right ways to do it. So if stack is less than 0, stack is greater than top of stack.length. So if stack is greater than top of stack.length, greater than or equal to top of stack.length, right? And then I'm going to throw a new index out of bounds exception. Like that. And then I also want to make sure that, well, actually, I'm going to want to make sure that I have a next available place to put it. So I also want to say that if next available is less than 0, then I need to, this is going to be the case if there are no more available slots in my array, right? So in this case, you could do multiple things here. I'm just going to fail silently because I don't think it's a huge problem if you can't push any more items. And you should ask your interviewer what they think is the best solution. You can propose some different solutions and sort of explain the benefits of each one, and that's a good way to choose something. But I'm just going to return here and not worry about it. And now I'm going to say that I'm going to cache my current index, or my next available. So current index is going to be next available. And because this is the current index that I'm adding into right now. And I'm going to say that next available is now equal to next index current index. Because that is the value that we stored in here, pointing to where the next available cell is. So next available equals next current index, and then I'm going to say that, so I want to set the stack data, so stack data current index equals value, and next I'm now going to reset next index, and next index is going to point to the current index because the current index next index is going to point to the previous top of the stack, because the previous top of the stack is the previous element in that particular stack. So next index current index is going to be equal to top of stack of stack, because we're getting the previous top of that particular stack, and that's going to be where we want to go after we pop this item off. And then finally, the last thing that we need to do is we need to set top of stack of the current of stack to be the current index, right? Because that is where we just added the most recent item to that stack. And so that's all there is to that. That's a little bit tricky because you have to make sure that you're storing all of the proper values and not resetting the value before you need to use it. So it's worth thinking through it a little bit before you actually write it out. Or what you can do is you can write it out and leave spaces between each line, so it allows you to, if you need to rearrange your code when you're doing it on a whiteboard, it's much easier to erase one line and put in 2 lines, whatever, than have to erase everything and start again. So it's a really good idea to try and do it, to leave spaces between, especially if you're not sure about the ordering or if you think you might forget a line or two of code. So next we're going to implement pop. So pop is going to return an int, and we're just going to take in our stack index. And so again, we want to double check that our stack is valid. So if stack is less than 0 or stack is greater than or equal to top of stack dot length, then we're going to throw an exception again. So throw new index out of bounds exception. And then we also want to see if the stack is empty, right? So we're going, because if the stack is empty, then we don't have anything that we can return. So we're going to, in this case, I'm just going to add an additional check to our current error handling. But you might want to throw a separate error for this, so you just have to decide what, you can talk to your interviewer and decide what you think the best way to do this is. But we can just check if top of stack is empty, then, so if top of stack equals -1 for that given stack, then we know that no item has been set into that stack. So we're going to throw the same exception. So if top of stack equals -1, then we also want to return the error, or is less than 0. Is actually, I think that's a slightly cleaner way to write it, but you can also write is equal to -1. So now we've checked that we have an element in that stack to return and that the stack is valid. So we're going to go and we're going to get the current, so we're going to say current index is now the top of the stack, right? So that is the element that we're actually trying to pop off. So int current index equals top of stack, and then we're going to, we want to get our value, and we're going to need to cache off the value. So int value is going to be equal to stack data current index, because that's where we stored our current index, or that's where we stored the data for that stack. And then we're going to go ahead and say that so we're going to set top of stack is now going to be equal to the next value from that current index, because the current index, when it's set, is referencing the previous value in the stack. So top of stack is now equal to top of stack is equal to next index get current index. Right? And then we're going to set the new next index, and now the next index is representing the next available, because it's now all of a sudden our cell, or our index, is an available index in our array. So we're going to now say that next index of current index is equal to next available. And so that way we know finally when we're going to set next available is equal to current index. And now if we add something, we're going to increment next available to what it was this time around, and then we're going to keep going, so it's going to work the way that we expect it to. And finally, we need to return value. So that is all there is to it for those two functions, and there's a lot of sort of intricacy there, so you need to be very careful. And this is part of why we always do testing, because the testing is going to make it so that we can catch any potentially fatal mistakes that we might make. So let's go here, and we're going to test. I'm going to use this example that I was using before. I'm going to modify it slightly. I'm going to say -1, -1, -1, because that's how I'm going to say that we're going to have a capacity, or I'm going to say we're going to have 2 stacks and a capacity of 3. So this is going to start as 0, 0, 0. And this is going to start as 1, 2, -1. And next available equals 0. And I'm just going to copy these down to where I need them. So let's just make sure that we're initializing things the way that we intend to. So we're going to call stacks of 2, 3. And we're going to, top of stacks is a new int num stacks, which is 2, which is length 2. And we're going to go through the entire length of that array and set them to -1. So we're going to end up with top of stack the way we expect. And now we're going to set stack data as capacity, which is 3. And we're going to get this because Java initializes this arrays to 0. And finally, we're going to go to next index, and we're going to set that to be size capacity. And then we're going to say for int I is 0 and I is less than 2, right? So when I equals 0, then we set the value to 1. When I equals 1, we set the value to 2, and then we break out. And finally, when I equals 3, when I equals 2, we set the value to when next in length is 3 and 3 minus 1 is 2, so we're going to set the value to be -1, and that's what we expect here. Now let's copy these elements down to, we're going to push a couple elements onto our stack and make sure that the stack is behaving the way we expect. And it's a little bit harder to test this thoroughly because it's an object rather than a specific method doing a specific thing, but we can test it well enough to ensure that we at least are getting the right general logic. So let's go ahead and I will call push of 0 and 5. And I'm just going to use slightly larger numbers so that we can differentiate all of our numbers. So we're going to get stack 0 and value 5. So 0 is not less than 0, and 0 is not greater than or equal to 2. So we're gonna, and next available is not less than 0. So current index is gonna be equal to next available. So current index is now 0. So let's go ahead and add that here. Equals 0. And now next available equals next index current index. So next index of 0 is 1. So next available equals 1. And stack data current index equals value. So stack data of 0 is going to be equal to 5. Then next index current index equals top of stack. So next index of the current index. So next index 0 is going to be the top of the stack, which is -1. And finally, we're going to come and we're going to say top of stack equals current index. So the top of the stack is going to be 0. Just like that. And now let's push another element just for kicks. So I'm going to push it onto the other stack, and I'm going to push 6. So I'm going to say, again, the 1 is not less than 0, and 1 is not greater than or equal to 2, and next available is equal to 1, which is not less than 0. So current index equals next available, so current index equals 1. Next available equals next index current index, so next index of 1 is 2, so next available is going to be equal to 2. Then stack data current index, stack data 1 is going to be equal to 5. So stack data 1, is equal to 6, which is the value. Then next index current index, so next index 1 equals top of stack. So top of stack is -1, and next index current index. So next index current index is 1, so this is going to be equal to -1. Which is what we expect, because for both of these stacks are the only element in the array in that particular stack. So the next element in that stack should be -1. And then finally, top of stack equals current index. So top of stack is going to be equal to 1. And now we want to double check that. So it would be good to probably do a couple more, but I'm not going to take the time to do that now. So I'm going to go ahead and now I'm going to pop some items off. So I'm going to do pop, and the tough case here is when we're popping, well, actually they're all tough cases. So I'm going to pop 0, so I want to remove this 5. And so I'm going to say stack is not less than 0 and stack is not greater than 2, and top of stack is not less than 0 because they've both been set. So current index is now going to be equal to top of stack. So stack is 0, and top of stack is 0, so current index is equal to 0. And now value is going to be stack data dot get current index, so value equals 5, and top of stack equals next index current index. So top of stack, which is this item here, is going to equal next index, which is -1, which is what we expect. And now next index of current index equals next available, and next available equals 2. So this is going to become 2, and then next available equals current index, which is 0. And finally, we return value. And so we get 5 back, which is what we expect. And now let's just double check that we're in the state that we want to be in. So if we were to push another value, we would push it to this 0 slot, and then we would basically go next available would then become 2. So we would come to here and push to the next, and then next available would be -1, and that's what we expect. And you can test this some more and make sure that it works the way that you want it to exactly, but I'm not going to take up any more of your time because it's already been a really long video. But you can see that this works the way that we expect it to, and it's a pretty tricky problem. It gets quite complicated as you go along. So hopefully you followed that all. I'm going to link in the blog post to a written description of how to solve this problem that is slightly different but is basically the same logic. And so that may be helpful to you. And again, let me know, comment on this video or on the blog post if you have any questions, and I will do my best to answer them, and I will see you again soon.